Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is getting started with Oracle Cloud infrastructure, which will cover the fundamentals of Oracle Cloud infrastructure, including cloud concepts, OCI structures, and core OCI services. That being said, I'd like to introduce Luis Lopez and Brandon Larry as our main presenters for today. I will hand it over to Brandon.
Awesome. Thank you, Borna. Hi, everyone. Welcome to the session today. Today, we're going to be focused on getting started with Oracle Cloud Infrastructure. This is a foundational training, foundational level webinar, and we're going to cover many of the different services available within OCI. Looking at the agenda today, first we'll talk about the foundations of OCI. We'll take a look at the overview of different OCI services, identity and access management, networking, compute, storage, database. And we'll also have a demonstration that covers identity and access management within the cloud. By the end of this presentation, you'll be able to comprehend the building blocks of OCI and understand how high availability and business continuity can be achieved using regions, availability domains, and fault domains. You'll be able to implement security tools like identity and access management, as well as networking security components to maintain a strong security posture on OCI. And you'll become familiar with the core infrastructure services in OCI, such as networking, compute, storage, and database, to help you design and build out environments on a cloud scale. If you have any questions throughout the session, you can drop those in the Q&A spot, and we'll address those as we move along. All right, so starting with the foundations of OCI, right? When you work with a cloud service provider or CSP, we have a shared responsibility model. So this slide here outlines that shared responsibility model, right? In blue, you can see what the customer is responsible for. And then in green, you'll see what the cloud service provider is responsible for. And there's different levels of service offerings. So on the left-hand side, you have an on-premise deployment, right? You'll be responsible for everything from user access and identity down to the physical hardware, the infrastructure, the data center, the cooling, the power, everything that comes with running your workload. When you move into the cloud, there's different levels of service, right? So we have infrastructure as a service, platform as a service or PaaS, and then software as a service or SaaS. With infrastructure as a service, a good example of this would be like a virtual machine running in Oracle Cloud. So the customer is only going to be responsible for user access and identity down to the guest operating system. So with infrastructure as a service, you have access to the OS level when it comes to computing. And then the CSP is going to be responsible for virtualization, the networking piece, infrastructure, and then also, the physical location, the racks, the physical data centers. With PaaS, a good example of PaaS would be like Oracle Integration Cloud or Oracle Analytics Cloud, right? The customer is going to be responsible for user access and identity down to the application itself, right? With some of these services, you can specify the amount of CPUs that are needed, but you don't have access to the underlying operating system, so you can't SSH into a PaaS service and change any of the underlying configuration. That's going to be handled and managed by the cloud service provider. And then with software as a service or SaaS, a good example of this would be like Fusion HCM or Fusion ERP. These are some of our SaaS products like enterprise resource planning. And as the end consumer of a SaaS product, you're responsible for managing and maintaining the user access and identity into that software, and then also the data that you put into that software, right? But as the cloud service provider, you won't have like Oracle will be responsible for the configuration of that application. So you won't have to worry about scaling. You won't have to worry about, configuring the underlying application. That's all going to be handled by the CSP all the way down to the data center it runs in. So there is a trade-off between, control and what you're responsible for when you move through the different service offerings in the cloud. So looking at our ecosystem, OCI offers a broad suite of over 150 cloud services in each region. And OCI costs less than other clouds, especially for foundational services, including compute, storage, and networking. And we have a broad range of options when it comes to different services available. Our core services are going to be compute, storage, networking. Of course, we have Oracle database available. There's open source databases available as well, like MySQL, Postgres. Different operating systems are available, integration tools like Oracle Integration Cloud, Oracle Analytics Cloud, containers. You can run Kubernetes clusters in the cloud, and then developer services as well. All of these services are going to be built out on our data centers. So when we take a look at our footprint, right, we have a pretty broad footprint across the entire globe. And Oracle Cloud is delivered by these globally distributed cloud regions that provide secure, high performance local environments. They're organized into separate, secure regions. So this gives you the ability to move, build, and run all of your workloads and applications on OCI while complying with any regional data requirements or regulations that you have. We offer services from 51 public cloud regions and 26 different countries. And each Oracle Cloud region offers a consistent set of services that are designed to run any application faster and move, and more securely for less. And what's nice about Oracle is that our pricing stays consistent across regions. But with this diagram here, you can see, in red, we have all of our available commercial regions. We also have government regions available as well, dedicated region options, and we also have some partnerships. So partnerships with Azure, Google Cloud, and AWS. So if you have things running in another cloud provider and you want it to be closely located to, some of the services that you have running there, you definitely have that option with Oracle. So the regions are going to represent geographical locations where Oracle provides cloud services. Within a region, you have different availability domains, and the availability domains are essentially one or more data centers that are located within a region, and they have independent power, hardware, and networking. So if you have a failure in one AD or availability domain, you can still be up and running in the other availability domains within that region. So if we take a look here on the right-hand side, right, we have our Ashburn region. If 81 were to go down for some reason, you could still be up and running in the other ADs within that region. So this is useful for high availability. When you're building out your workloads, you can, build it out across availability domains within that region. And you'll have the choice where you want to place your services when you deploy them. So if you deploy a virtual machine, you'll be able to choose, which fault domain, which availability domain you want to place those in. The fault domains represent groupings of infrastructure and hardware within an availability domain. So what's unique about Oracle versus some of the other cloud providers is we give you that option to select within the data center which fault domain you want your services to be running in or your computing resources to be running in. So that's unique to Oracle, and it's very useful for high availability. So within an AD, you can also be highly available, right? You can set up your virtual machines to be running across fault domains within an AD. And again, they're isolated from one another. And if there were a failure in one of the fault domains, you would still be up and running in the other fault domains. All right, so let's get into some of the different services. So first off, let's take a look at security. So this slide here does a good job of outlining many of the different security services available within Oracle Cloud across the different domains, from identity all the way to internet and edge. So identity is a little bit lower here on the diagram because identity and access management is a fundamental concept when you're operating in Oracle Cloud. And it comes into play when you're dealing with any of these other services. By default, your users will not have permissions to interact with any of these other services, and you'll have to grant them permissions where appropriate. So, as an example, if one of your users wants to interact with the Bastion service or networking, you'll have to grant them permissions to be able to interact with those services. So under identity, we have some things like role-based policies, right? One of the best practices is to set up service level administrator groups. You can have a networking administrator group, a database administrator group, compute administrator group, compartments and tagging. So we'll get into this in a couple slides here, but compartments are essentially logical containers for related resources, and they act as that access control boundary when you're operating in the cloud. Under data, we have some things like data safe. We also have a vault service, so you can manage your encryption keys and your secrets with our vault service. All of those things are going to be stored on HSMs or hardware security modules. And we also have data safe. So data safe essentially is a single pane of glass view when it comes to security of your Oracle database fleet. And you can run different assessments. You can see, user activity and detect if any configuration changes within your Oracle databases pose a potential security risk. Under compute, we have some things like our certificate service, so you can manage your certificates within Oracle Cloud. You can also be aware of any like upcoming expiration if you need to rotate those certificates. Under networking, virtual cloud networks, so our included firewalls are going to be the security lists and network security groups. That's like the fundamental security piece when it comes to virtual cloud networks. But we do have some other services as well, such as our network firewall and then our web application firewall. We also have a Bastion service. So instead of maintaining a traditional jump host or jump server, we have Bastion as a service, and everything is going to be governed by identity and access management. And you can leverage the service to create, time-bound connections to private endpoints that are within your VCN. We have a broad range of different gateways, and there's many different use cases for each one. Monitoring and prevention tools. So we have things like CloudGuard. CloudGuard is going to go in and scan your tenancy and what you have deployed for different problems. And it's going to pick up on different configuration issues or user activity issues that might pose a potential risk. There's also some other tools like security zones, so you can lock down your compartments and explicitly deny actions from taking place. Vulnerability scanning is a useful tool to mention here when you're looking at the security of your computing resources. So when it comes to, scanning container instances or container images, and then also it can scan virtual machines for open ports and detect any vulnerabilities that may occur. And then under Internet and Edge, so we have DDoS protection. That's going to be built in to OCI layer 3 and layer 4. DDoS protection is built in, but we also have WAF protection. And with WAF, you can enable layer 7 DOS protection. You can set up rate limiting. You can set up protections against many of the OWASP defined vulnerabilities. And you can also set up access control rules. So just to kind of summarize this slide, this does a good job of outlining many of the security services, kind of broken down by domain here. But again, the core piece is going to be identity and access management. And by default, when you create a new user in the cloud, they're not going to have access to these services until you explicitly grant them access through policy statements. All right, so identity and access management. So identity and access management is the identity as a service solution within Oracle Cloud. So it's going to be used for governing access to your Oracle Cloud resources, but it's much more than that. It can be used for access governance for a broad suite of different applications, whether they run in OCI whether they run on premise or whether they're, third-party applications. It's essentially a full-featured IDaaS solution for many different scenarios. And you can kind of see here some of those scenarios. We have access management, directory services, identity governance, role intelligence, lifecycle management. It's going to be used as the identity store for many different applications. And it also provides options for multi-factor authentication as well. So if you've been around Oracle Cloud for a while, we used to have a standalone IDaaS solution, and that was IDCS. We took all of the features of IDCS and we've integrated those into the OCI IAM. So it's all native now to OCI, and everything is unified into that, single solution instead of having two separate solutions. So the benefit of that is you get all of the features of IDCS without having to manage and administer a separate IDaaS solution, right? It's all integrated in IAM, and IAM acts as that identity store for all of these different applications. There's also a built-in app catalog with over 1,000 different application templates that are pre-configured. So it will help you facilitate those types of integrations to different third-party applications. It can be used for, managing identities on OCI, your SaaS apps, your applications that you have running, third-party applications, and then also apps that you may have on premise. All right, moving on to compartments. So a compartment is a logical grouping of related resources that can be accessed only by groups that have been given permission. At the highest level, you'll have what's called a root compartment. So you can see that here on the screen. It's this gray dotted box here. And all the other compartments that you create will fall within this root level compartment. So you can see here, I've added in some compartments, and typically you'll organize these compartments by environment or by team. I've seen it work well when you organize them by environment. So you could have one compartment specific to an application, and then underneath that compartment, you could have, development environment, production environment, testing environment within that. So there's a hierarchy to these compartments, and you can see that here in the visualization. Again, at the topmost level, you'll have the root compartment, and then within that, you can customize the structure however you want to lay it out. In this example here, we have it broken down by team. So we have a marketing team, finance, infrastructure team. And when we add some resources in, you can see that here. So in our infrastructure compartment, we have our infrastructure virtual cloud network. We have our different subnets, our gateways, our load balancer. Right. Every time you create one of these resources, you'll have to specify which compartment you want it to be placed in. And the compartment is going to essentially act as that access control boundary. So you'll write policies to enable different user groups to be able to interact with the resources in a particular type of way within these compartments. So here on the top right, you can see our different groups. We have an infrastructure administrator group, shared service admin group, identity and access management administrator group. Let's take a look at the green group, the infrastructure admin group, right? The hammer on the corner of this compartment specifies policy statements, and that is how you will grant a group permission to interact with the resources. So in this example here, the infrastructure admin group, they have access to the infrastructure compartment. They can go in and they can create a virtual cloud network. They can change the route table rules. They can change the firewall rules and the security list. They can create new gateways, but they don't have access into other compartments, right? They only have access where your administrators grant them access. And in this case, it's just the infrastructure compartment. So they can't go into shared service compartment and make changes to analytics cloud service, or they can't go into the enterprise application compartment and make changes to the computing resources. And this is useful, right? Because you can separate these compartments, like I mentioned, by different environments. So you could say, all right, well, this group is going to have access to our production environment, and this other group is only going to have access to our development environment. We also have the example here of the shared service administrator group in blue, and they have access to the shared service compartment. So they can access analytics cloud service, they can make changes to the instance, but they can't go into the infrastructure compartment and change the networking resources, right? They just don't have permission. And they can't even see what's running in that compartment unless you grant them a specific permission. And we'll get into that in the next couple of slides here, what the different permissions are. But essentially, there's manage, read, use, and inspect. And to even be able to view what's running in a compartment, you would need that inspect permission. One more thing before we move on is that these compartments can also be used for cost attribution. So when you're doing your cost analysis reports, you can break those down by compartments and you can see exactly what you like the cost of what you have running in these compartments broken down on that cost report. So let's talk about who gets access. So we have the concept of principals within identity and access management. And that's going to be an entity that's allowed to interact with other OCI resources. We support the idea of least privilege. So that means that users will have no access until they're added to a group, and then policy statements are written to grant them access. Upon creation of a user, you can add them to groups, but you can also add them to groups later, and you can, remove them from groups. Let's say you have a user who is part of a database administrator group, and then, they're no longer part of that group, or they no longer need that specific permission. You can easily remove them from that group. So users are going to represent people. They're persistent identities that you set up within identity and access management, and they represent people. From there, you'll add them to groups, and groups essentially are collections of users that will need the same type of access. So this ties back into that best practice that I mentioned, right? Service level administrators. So you could have a group for database administrators, a group for networking administrators. Instance principals will let instances make API calls against other OCI resources, removing the need to configure user credentials or create a configuration file. So you can set up instance principals, and the way to do that is to add an instance to a dynamic group via a set of matching rules. And the matching rule essentially is, like an OCID or an entire compartment OCID. You can specify that you want every instance in this compartment to be part of this dynamic group, which will enable them to make API calls to other OCI services. So these are the two different types of principal entities within Oracle Cloud, right? You have users, and then you have instance principals. So instance principals just let instances make API calls against other OCI services. And then users would be people. So let's get into access and authorization. So for authorization, you'll define specific privileges through policies and attach them to compartments. So here we have two policies, two compartments, two groups, and two different users. So this is a great example to walk you through how this works and how it looks when you're operating in OCI with compartments. So policy A, we're allowing the group in identity domain A, group A, to manage compute in compartment A. So if you're a user that's part of group A, you'll have access to manage compute in compartment A. So you can go in, you can turn on new virtual machines, you can stop existing virtual machines, terminate existing virtual machines. Manage is going to give you the full permission set when you're operating in the cloud, right? So inspect, on the other hand, if we look at policy B, Inspect is just read only. So they'll only be able to read what is running. They won't be able to actually go in and create virtual machines or stop what you have running. And this could be useful for like an auditors group. If you have a group of auditors or someone who needs to like keep tabs on what you have running, just needs to get a list of what's available, you can use that inspect permission. So policy B, we're allowing group from identity domain A, group B to inspect compute in compartment B, right? So if you're a user that's part of group B, you can go into compartment B, you can list and see the virtual machines that are running, but you cannot go into compartment A and see what's running in compartment A. You have no permissions over in compartment A. It's only in compartment B where you could, list what's running. You can't go in and change things. Inspect is essentially read only for what you have in that compartment. So these policies and these compartments are hierarchical, right? You can write policies for your administrator groups at the tenancy level. So essentially at the root compartment level, and that would automatically be inherited to the child compartments within the root level compartment. So if you were to, change this first policy, and instead of saying in compartment A, you say in tenancy, then this group A would be able to manage compute in the entire tenancy. So they would have access to compartment A, they'd have access to compartment B, and it would grant them access to the entire tenancy. So with that being said, where you attach the policy is going to define who can modify or delete it. So these policies are all in the same format. They always allow. So like I mentioned, we use the principle of least privilege. So by default, everything's going to be denied when you create a new user until you add them to a group and write policies for that group. So you're only going to be allowing access where appropriate. And this is the syntax. So you're allowing a group. So in this case, DB backup project A, and then you specify the type of access. So to do what? To manage, to use, to read, to inspect. Manage is going to include all of the permissions for the resource, and then inspect is essentially just the ability to list resources. You can see it here broken down. So these are the different verbs: inspect, read, use, and manage. And then you'll specify the resource type. So you can use an aggregate resource type or an individual resource type. With an aggregate resource type, it's essentially a collection of the individual resource types, and it makes it easier to write policies because, instead of listing out each resource type, you can just use the aggregate. In this case, right, if you're writing it for network administrators, you might want to give them access to the virtual network family, which is going to include the VCN, the subnet, route tables, all the networking resources. But if you're just writing it for someone who, let's say, is working with database backups or block volume backups, right? There's specific resource types for that as well. So in this case here, if it's for block volume backups, you could just give them access to the individual resource type, which is volume backups. But you can see how it's broken down, right? And it's important to only grant access where appropriate. You never want to grant too much access to users. After you specify the resource type, you're going to specify in a compartment. So in this case, in compartment project A, or it could be in tenancy. So if you specify in tenancy, that's essentially granting them access to do whatever you specify here in the entire tenancy in all compartments. So in this case, we're just granting access in project A compartment. And then optionally, you can have a condition at the end. So it could be like a tag or where request region is Ashburn, right? You can have a where condition at the end of the statement to get more granular and specific with the policies. All right. So now we have a demonstration. I'm going to hand it over to Lewis, who will take us through a demonstration on users, groups, and policies.
Thank you, Brandon. Appreciate that. So you should be seeing my Oracle Cloud Console homepage here. We're going to do a quick tour of the console, and then we'll go into some of the users and groups, how to set that up, and policies. So here you can see our console homepage. You can see some things right off the bat. So first off being our resources, are recently viewed, recently created, or our custom resource collections. You can set that up here as well. On the right-hand side, you also have a build section. So this has some common use cases for you to get started with, whether that's creating a compute VM or ATP database or ADW, or just simply setting up your network. You can do that here from your homepage. If we scroll down, you have a list of some of your recent services that you've interacted with here, some service spotlights, so you can customize these recommendations, but might just highlight some certain services for you if they have some new features or whatnot. You also, if you keep going further, you have some what's new documentation links, so you can learn about what's going on in OCI. And then going down a little farther, you have some recommendations for cost savings on the right-hand corner, and some quick starts for different use cases that you can get started with. If you just want to get your feet wet with certain services, you could take a look at that there. And then again, of course, we do provide lots of documentation links throughout the console. So if you're not sure of something, you can always click into it and get a deeper view into the documentation there. And then down at the very bottom, we do have announcements and alarms. So if you set up notifications for your resources or anything like that, those will show up here if you hit any critical thresholds that you've set up. If we scroll back down, back up to the top, in the right-hand corner, you'll notice a little drop down that says US West Phoenix. This is where you're going to go to change a region if you have multiple regions within your tenancy. So you can do that here. If you go over one more to the right, under developer tools, you have access to Cloud Shell and code editors and notifications for announcements and stuff like that. So that's our homepage in a nutshell. In the top left-hand corner, you'll notice a little hamburger navigation menu. And this is where we go to access all of our different services within OCI. So whether that's compute, storage, networking, database, developer services, identity and management, stuff like that, billing and cost management, governance and administration. But today we're going to be focusing on identity and security. And so from here, I'll take you through what it looks like to create users and groups and policies from here. So with identity and security, we're going to go under the identity column and find domains. So these are our identity domain that you can see we have set up here for our production environment. So if we click on here, we can actually see our our domain details here. If we go to user management, this is where we can add our users and groups. So you can see we have a prod user at Vision Corp here, but if I were to want to create a new user, I could do that here and hit create. I give it a first name and last name, and then the email. Oops, sorry about that. I can type. And from here, you can use you have a little checkbox here that says use the email address as a username. Typically, that's what we recommend. But if you have a requirement for a separate username, you can uncheck that there. Pretty simple process for creating a user. But one thing I want to draw your attention to is if you keep scrolling down, when you create a user, you have the option to automatically add them to a group. So that may already be created. So if I wanted to add myself as a domain administrator or all domain users, I could just check the relevant boxes that I want that user to be a part of. So whenever I create the user, it will automatically be assigned to those groups with the relevant permissions for those groups. So that's pretty simple there. I'm going to go ahead and cancel and hit instead of creating a user there. And then vice versa. Alternatively, if you go to groups, you can create a group from here. So again, similar process. We can create group. We can give it a name. We can say maybe it's something like network admins. Give it a description. And then you can also, toggle this switch for user requesting access. Might not want to do that for an admin group, but for any other groups like maybe like an HCM or ERP related group or something like that, if you have those categories, you can have users request access. And then just like we saw on the user screen, when you're creating a group, you can automatically select from your list of already existing users to add to that group once it's created. So, if I had production user and then if I had, myself, Luis Lopez at oracle.com here, I could check those boxes. And then when I create this network admins group, those selected users will automatically be added to this group along with the appropriate permissions. So again, I'm going to hit cancel there instead of creating a new group. And I'm going to go back one actually so that we can go to our policies. So if I go to identity and security again, under identity, we can find policies. So this will give you a list of the existing policies that you have. To create a new policy, again, you're going to hit this create policy here. You're going to give it a name. I'm going to put it test policy. Now test there. Now from here, you're going to select your relevant compartment that you want to select that you want this policy to apply to. And here you can see we're under Vision Corp, which is our fictional company here. And if we scroll down through this list, we can see infrastructure. So this is the compartment we want it to be in. And if we go down a little farther to the policy builder, you can see we have several drop downs. So these are a quick way to build your policy based on common use cases. So you can select your policy use case. In this case, we're doing infrastructure. So maybe we want to do something like compute management, right? So we want to give permissions to users or a group to let users launch compute instances, for instance. So we can select that there. And this gives you a little excerpt of what this is intended to do. So ability to do everything with instances, launched into the cloud network and subnets in the selected location, et cetera, et cetera. So that's one way to build your policies. Again, you can change this based on what you need specifically. And if you need something more granular than this, you also have a manual option. So you can show the manual editor where you can see, this is based on what we have selected through the dropdowns, but this is essentially the syntax that Brandon went over earlier in the slides to set up these policies, right? So you can see allow group production, that's our domain, and then you can insert the group name. So in this case, it could be, infrastructure group or whatever we choose to call it there. And then you have the rest of the statement here. So to manage, which is the highest level of access, instance family and compartment, team compartment, Vision Corp, information services, and infrastructure. So that's the path to our compartment that we've chosen. And so you can see how granular you can get with these. And you also have the option to add your where conditions just in this as you got in the sample statement down here. So if you click into this box, you'll see a little example statement here pop up at the bottom of the box. So with that being said, that's our quick little demo. We wanted to give a console tour and show some of the IAM policy, concepts that we covered in the slide deck. So at this point, I will go ahead and switch back over to the second part of the presentation. So we'll pick up from here. Before you set up your network in OCI, there's a few concepts to be aware of that you can see here on your screen. Starting from the left is your VCN. This will likely be one of the first things that you set up in your tenancy as you begin to create new instances. VCNs are your software-defined networks where you'll be deploying your instances within a set IP range. And you can think of these as your data centers in the cloud, if you will. And you'll additionally configure route tables and firewall rules upon your VCN creation, but you can also do that after the fact. Each VCN is subdivided into subnets, and each subnet can be either public or private. You can have more than one subnet in an AD availability domain for a given VCN. And one thing to make sure of is that you don't have any overlapping private IP space in general, so no overlapping CIDRs or anything like that. If you move one over to the right under gateways, there's a few gateways to be aware of. Starting with an internet gateway. An internet gateway provides a path for network traffic between your VCN and the internet, and you can have only one internet gateway for a single VCN. After you're creating your VCN and internet gateway, you're going to have to add a route for that gateway in order to enable traffic flow. Additionally, you also have the concept of a NAT gateway, which gives an entire private network access to the internet without assigning each host a public IP address. This allows hosts to initiate outbound connections to the internet and receive responses, but not receive inbound connections that are initiated from the internet. Additionally, you have a dynamic routing gateway, which provides a path for private traffic between your VCN and destinations other than the internet. You can use it to establish a connection with your on-prem network via IPsec VPN or FastConnect, which is a private dedicated connectivity with that's backed by an SLA. And you can also use your dynamic routing gateway to establish a remote or local peering relationship between two different VCNs. And then finally, you have a service gateway, which lets your resources in a VCN access public OCI services, such as object storage, but without using the internet or a NAT gateway, so it does not traverse the public internet. And then finally, in terms of firewall rules or firewall capabilities, you have security lists and network security groups that are two firewall options you have available to you within OCI. Security lists let you define a set of security rules that applies to all VNICs and an entire subnet. To use a given security list with a particular subnet, you'll make that association during the subnet creation, but again, you can also do that after the fact. And then network security groups let you define a set of security rules that apply to a group of VNICs of your choice. So if you have a set of compute instances that all require the same security posture, you can use your network security groups to achieve that. Next, for compute, OCI provides flexible, high-performance, and secure compute services for any workload, which includes AI and machine learning, compute-intensive workloads, enterprise workloads, and even cloud-native applications. Bare metal instances here on the left-hand side provide customers with isolation and control with dedicated physical server access. Customers can run demanding workloads on these instances that scale up to an industry-leading 192 cores, 2.3 terabytes of RAM, and up to a petabyte of block storage. We also have dense I/O bare metal shapes for these instances, and these are bare metal instances that are equipped with high-performance local NVMe storage that are optimized for large databases and big data workloads. Moving on to the right, virtual machines. These run a wide range of workloads from small development projects to large-scale global applications. You have your choice of AMD, Intel, or AMP shapes with network bandwidth that scales with the number of cores that are selected. Moving one more over to container instances, you can easily launch one or more containers with the flexibility to specify your compute shape, your resource allocation, networking, and other optional configurations. And they run in a dedicated environment with strong isolation for improved security. And then finally, OCI Functions is a serverless compute service that lets developers create, run, and scale applications without managing any of the underlying infrastructure. Functions typically run for short durations, they're stateless, and they run for a single purpose of logic and then spin down. For storage, we have several storage options available to you. Starting on the left-hand side, local NVMe provides the fastest performance for transactional databases and HPC use cases. Block storage is the most flexible for application development and deployment and persists beyond the lifespan of a virtual machine. So you can swap these in and out, attach it to new virtual machines that you spun up, and use them that way. We also offer a managed file storage service that has massive scale, making it ideal for enterprise applications, big data, analytics, scale-out applications, and container-based applications. For object storage, which can store an unlimited amount of unstructured data of any content type, including images and videos, this is immediately available to you and is a regional service and natively redundant. Archive storage is our durable long-term compressed data storage. It's much cheaper than object storage, but you should note that the data stored there has to be restored before you're able to retrieve it and use it, unlike object storage, which I mentioned is you can retrieve instantaneously. And for database, we have a few different database flavors here. Starting from the left-hand side and moving to the right, you can see it moves from more customer managed to fully managed and automated. But from the left-hand side, Oracle Database on Compute, typically we see these with these deployments with customers that have extra database licenses that they're trying to make use of, and maybe they have applications that are running in various other clouds where they want to have their database close to those applications, and maybe they have additional options that they've licensed for those as well. So they run it on a compute instance just to make use of everything. With that scenario, you as a customer would be responsible for basically everything, the licenses, the underlying infrastructure that it's running on, the data that's in the database, etc. With the Oracle-based database service, moving one more to the right under the co-managed section, this is our database service within OCI. It comes with all the Oracle database options available to you there. And it comes in standard and enterprise editions, just like you're used to. Also has automated backup and patching, auto transparent data encryption as well built into it. And that's our, basically our normal database offering in the cloud. If we go one more to the right, Oracle Exadata database service. This is meant for extreme performance, scale out workloads. Very intensive workloads, and maybe we mentioned earlier some data residency regulations that might need to be met. This is a perfect fit for that for Oracle Database because Exadata is able to be deployed in a cloud at customer deployment. So what that means is it's deployed and installed behind your own firewall in your own data center. And that way you have access to Oracle services within your own data center to meet those either data residency requirements or latency requirements. And then finally, on the far right, we have Oracle Autonomous Database meant for any workload, any scale, any criticality. It self-patches, it self-tunes, it's auto-scales, and is available in either serverless or dedicated deployments. You have a couple different flavors for data warehousing or transaction processing, but this is fully managed. You don't have to worry about the underlying infrastructure or doing any of the menial maintenance tasks that we mentioned that are automated, fully managed, and you just have to kind of worry about the data that's in there. Now, Oracle Database 23 AI is our next long-term support release and brings additional capabilities that were not previously available that are built for the developer. So whether you're looking to build applications to support millions of connected users, or you're looking to build data warehouses to process billions of rows, 23 AI brings you a whole raft of new features to help make this happen. Oracle Database not only supports relational data, but it also supports XML, spatial graph, key value, and JSON models, all in the same database engine, with all the models benefiting from Oracle industry-leading performance, availability, and security. On top of this, data stored in all of these models can be used together without any costly integrations. Some of the marquee features in 23 AI include the JSON relational duality, AI vector search, true cache, and SQL generation with Select AI. And additionally, Oracle 23 Database 23 AI runs everywhere, whether that's Cloud at Customer, on Exadata engineered systems, on OCI, VMware, multi-cloud, which is really great. So again, great for those split stack type of architectures, where you want to have, you might want to have your database right next to your application. So we can do that with database at Azure, database at AWS, or database at GCP. So we have partnerships with all three. And as far as monitoring and managing your OCI resources, you have a couple options here. So monitoring, OCI has many monitoring capabilities that are built in, where DevOps engineers, IT operators, and site reliability engineers can gain critical insights on your cloud infrastructure and workloads with out-of-the-box metrics. You can optimize utilization and track infrastructure health while detecting and fixing anomalies using queries. And for logging, you have a single pane of glass for all your logs. So whether they're your service logs, audit logs, custom application logs, or your security logs, you can find them all in one place. For notifications and alarms, this allows you to receive messages from applications and services. You have guaranteed delivery to email, Slack, PagerDuty, and other third-party apps. And it's very tightly integrated with Oracle Identity Management as well. And then finally, for Resource Manager, this provides Terraform as a service. So IT operations teams can easily and reliably deploy and manage Oracle Cloud resources with this infrastructure as code service. You can use an unmodified open source code base to simplify migrations from and to other environments as well. So some of the key takeaways here. You can design solutions to have multiple regions, multiple availability domains, or multiple fault domains, depending on the class of failures you want to protect against. You can also use identity management services to authenticate and grant permissions to users, partners, customers, applications, services, or other entities. You can set up your networking components, your VCNs, your gateways, route tables, and firewalls to maximize your security posture. And you can identify your application performance and manageability requirements early on to help choose the optimal compute, storage, and database deployments for your needs. So with that, I will go ahead and pass things over to Olivia to close this out. I know we're coming up on time here. So Olivia, you want to take things from here?
Yep, thank you, Lewis. So this slide is just another way of learning more. So there's Oracle University and some learning subscription paths right here. There's also some live labs listed. So if you want more hands-on experience, there's several ways of doing so listed here. And then we have some documentation. And then on the next slide, we have our Day One and Beyond program here. So this is more one-to-many, open to everyone. We cover a variety of different topics in OCI. But if you want more one-on-one training with you and your team, we do offer personal training. So this will also cover a variety of different topics in OCI, and it's a mixture of demos and slides. We also do offer one-on-one sessions for a quick shot live labs. So if you want more hands-on experience or more personalized training, we do have these options. And at the bottom of the screen, you can email us for more information. Additionally, there's also our Code Innovate program. So this is a 5 half-day online event where Oracle engineers will help you co-develop a use case. We've also listed the email down here below as well. And then on the last slide, so we have our core series here, but we also do have other series as well covering analytics, hands-on, cloud native, cloud security, and did you know? So please feel free to explore these different programs here. And then lastly, we have our next session on July 15th at 10 a.m. Pacific over cost management and governance. So we hope to see you all then. Thanks, everyone.